Welcome to Space Startup News Live. I do this live stream every week at the same time. I go over the videos I posted this week. I bring up comments people have left about the videos, and answer any chat questions. So it's the same format every week, so it's great if you can join. If not, you can watch it afterwards. So let's get on with the first two videos. But first of all, there's already a chat question from Alfredo. Thoughts on NASA's Tracer mission updates. So I had to look up the information on this. But NASA's Tracer mission stands for Tandem Reconnection and Cusp Electrodynamics Reconnaissance Satellites Mission. It involves two identical spacecraft designed to investigate magnetic reconnection in Earth's magnetosphere. So if you're not aware, there was some problems with the satellites. There was an anomaly that happened in August of this year, probably related to the power communications, and it prevented the satellites from being commissioned correctly. So there is an update this month, in September. NASA has successfully regained contact with the first satellite after months of issues with it. So now the engineers are working on recovery of the mission so they can do the science operations. So hopefully everything goes well with that mission. He also has a question on Apex Space. So the information on that is, if you're not familiar with Apex Space, they're a satellite company. They build standard satellite buses, and they host payloads for commercial and government missions to do with Earth observation, Earth imaging, also missile tracking sensors. So they had a big funding round in September, and they received $200 million. $200 million was invested in the company. Andreessen Horowitz and various other investor companies. So the company is now valued over $1 billion. So that basically means unicorn status if you get over $1 billion, and that was in 3 years. So they're doing really well. So that's the update on Apex Space. So the first video I did this week, we can bring this up. There it is, was Lunar Sabre deployable mass for the lunar surface. So I was looking at the Lunar 10 study from DARPA, which asked various commercial companies to come up with ideas for commercial services they could offer on the moon to do with lunar infrastructure. One of the proposals was from Honeybee Robotics, which is now owned by Blue Origin, by the way, if you weren't aware of that, and I wasn't at the time. But in 2022, Blue Origin took over the company. So they build, the concept is very simple. They build very tall towers that can be deployed on the moon. And at the top of the tower, you can put various different payloads. So you can put cameras, you can put LiDAR for laser ranging, you can do communications, power beaming, searchlights. There's many different concepts, I think, payloads you can put on them. And so the idea is that you put them in various places. In fact, have a look at this one here. So you can see there's two or three masts there. And you've got the Wi-Fi signal, you've got this kind of optical power beaming, the green light, and then you've got the orange one, which is just communication. So you can have a network basically by putting the masts, within range of each other. They can communicate with each other, and they have various different. I think I've got the graphic for I've got the graphic here for the various different versions. So they have this LAMPS one, which stands for, it stands for Lunar Array Mast and Power System. So this is about 16 meters tall, and it can produce 10 kilowatts of solar power It can unfurl solar arrays, and so you can put it up, and you can also take it down and move it. And the same with the LS15 mobile, as the name says. It's got a rover at the bottom, so you can just move it somewhere else, put it up, take it down. And then they have two bigger versions that cannot be restowed. Once you set them up, that's it then. So there's an LS30, which is 30 meters, and then the massive one, which is LS100, which is 100 meters high. So the advantage of the height is, well, with the 31, you've got a 20-kilometer distance. And I think there's another graphic here. Yeah, I think it's this one here. So you can see with the LS30, you see the orange circles. That's the distance that it can cover, which is 20 kilometers. So if you lay them out like in this graphic here, 20 kilometers away from each other, you've got a continuous path where you can communicate. And the blue circles is the LS100, which is 100 meters tall and can communicate over a distance of 37 kilometers, which is huge. For example, Shackleton crater has a diameter of 20 kilometers. So potentially one LS100 between or near the Artemis Base Camp would be able to communicate between the Artemis Base Camp and the opposite side of Shackleton crater with just one mast. So the idea is you lay them out around the South Pole, and you can communicate with rovers, satellite experiments, and anywhere over that range, and including the floor of Shackleton crater or other craters. So it's a very simple idea, but quite powerful, and the payload capacity is huge as well. The LS30, you can put, I think it's 300 kilos on the top deck, and for the LS100, you can put 1,000 kilos, 1 ton of payload. So you don't have to decide what one thing to put. You can put many, many different things. I think there's a graphic here. So, for instance, you've got comms, PNT, which is position, navigation, and timing. So you've got kind of GPS kind of ability. You've got, this is fiber tech. This is wireless power transmission. It's optical power beaming. You can beam power to a remote rover or a satellite, scientific equipment. Or, potentially you can beam power to the crater floor. You've got security cameras or asset management. This is great for the lunar rail system, which I'll talk about later. It's that you could have cameras and lighting on the track, so you can see any obstacles or any problems or any issues. So I think it's a very powerful concept. You've got power, you've got energy storage, you can see here. So you've got battery backup. So this gives you basically 24/7 power throughout the lunar day-night cycle. Because if you're in the South Pole, you get solar power, you get the sun practically all the time, 85, 90%. And at 100 meters above the surface, it's 95%. So practically all the time, you can see the sun. And there's a few occasions you can't, because you've got battery storage. You can still use the battery to send power. So your cameras, PNT, laser, communications, power beaming, and 360-degree cameras. So that's the idea of Lunar Sabre, and and this is from Honeybee Robotics. So this is just a study, and that's as far as it went. But they do have hardware. They built the deployable masts. They tested them. I think in the video you see the LAMPS version being tested, being deployed and then restowed, with the solar panels being deployed and restowed again. So it's a working system, and it is available for NASA. And I think it's just a great concept, very useful for space startups. For instance, I I think I mentioned about Icon Technologies wanting to build lunar launch pads and landing pads. Well, if you've got the power already, you've got the communications, you've got the lighting, you've got the cameras, that's a lot of stuff that you need that is just already provided by a Lunar Sabre mast. So it just speeds up a lot of infrastructure projects on the moon. It helps science projects, it helps rovers. It's just a great idea. One thing that it can't do is it can, for instance, you see the crater here. It can provide enough light to illuminate the crater. This is Shackleton crater. So if you put mass around the edge, you think, okay, that would light up the crater. Well, if you do the math on that, it can't. It can provide nowhere near the light you need. And that is because the crater is massive. The crater floor is about 50 to 75 square kilometers. So you can't light that kind of area. So NASA's baseline option to do that, I include it in the video, is you use, these are heliostats. They're just solar reflectors. So the light from the sun comes in, hits the reflector, and then it bounces down to the crater floor. So you'd have 10 or 20 of these around the crater rim. And these would be quite large, I think 10 to 20 meters, and they would just basically reflect all that sunlight onto the crater floor. And that would give you, it wouldn't give you a great amount of illumination, but it would be enough that you could safely do operations. And in addition, I say in the video, you could use nuclear powered illumination, LED floodlights powered by a nuclear power plant, and you could have different work areas. I think, like I said, 20 work areas, each one with 5 kilowatts of lighting, and you could see what you were doing, basically. So that's how you do the illumination. It would be through these heliostats, not through the lunar masts. So there were a few comments on this video. Marty the Martian is saying, okay, I've got a few chat messages. So live show this time. Yep. Okay, so solar is not light and batteries are heavy. Yes. Yeah, so I mean, it uses solar arrays, so that's the best way of getting power if you have access to the sun, and with battery as a backup, of course. And also saying, would not trust to send or use one tower. It would be smart to have multiple smaller units. Yeah, so the idea is there's a whole range of these. You have a whole range of them as a network. And the reason is asking why go in the crater. There's plenty of flat surface on the moon. The reason you want to go into the crater, see Shackleton crater here, is we suspect very likely there's lunar water ice. You can excavate the lunar water ice. You can provide heat, trap all the water ice, and then you have water for drinking water. You can split the water into hydrogen and oxygen for propellant. Oxygen is, of course, for life support. So lunar water ice is a very important resource for the moon. So you don't have to keep shipping water from Earth and so on. So NASA wants to go back sustainably, which means living off the land locally, in situ resource utilization. So you have to find those areas where you have valuable resources. And you find those in these very cold areas here, like Shackleton crater. The sun never gets into the crater, so it's extremely cold, and it traps all those volatile compounds and molecules like water. So that's why NASA wants to go to the crater, and he wants to investigate the crater. So in terms of comments, Marty's saying this is one of those technologies that amateurs like myself would never have thought of as necessary, but when presented, the need becomes obvious. Yeah, it's a very simple concept. It's a tall tower with stuff you put at the top, but it's quite powerful and very, very useful for NASA, for science missions, for rover missions, and for startups working on lunar infrastructure. And Rural Jura 420 says, this is so cool and obvious once presented, yet not something I or most people would have thought of. Very cool. Is NASA going to be buying any? Well, it's a study, but the hardware exists. It's been built, so it's been tested. At least the small version has been tested. So hopefully we see it on a future mission. I mean, it's such an invaluable thing to have. And since it exists, hopefully we will see it on a future lunar mission. And Michael Hennisley says, I really enjoyed this episode. It got me thinking about multiple layers of infrastructure. Yeah, me too. So I covered, last week I covered lunar roads. And my next video will be, the video that I did this week was on lunar rail. And I think I'm probably doing another lunar infrastructure video next week. So there's a lot to cover because a lot's happening when it comes to lunar infrastructure. And of course, this infrastructure you can use on Mars. You can use these towers on Mars, you can use roads on Mars, and you can use rail on Mars. So Bobola1 says, great idea here. There will no doubt have prototypes on the moon by 2030, question mark. I think Blue Origin's cargo hauler autonomous lander needs to happen as well, if not supplied by another company. Makes sense to me to squirrel away supplies in a landing base area. Before we maroon 3 or 4 astronauts up there, they are at risk for every need that us Earthlings take for granted. So the Mark 1 lunar lander from Blue Origin could fly by the end of this year. If not, then early next year. And then you've got Mark 2, which is a human version. So the Mark 1 can deploy the larger versions of these masts. I think it can deploy 3 tons of payload, so it's quite capable lander. So hopefully we see that soon. It could beat SpaceX to the moon. And in terms of making sure you pre-stage cargo on the moon, I think it's less important for the moon because the moon's only 3 or 4 days away from Earth. But it's absolutely essential for Mars that there's a lot of pre-positioned cargo. Ideally, enough supplies that the years of supplies, so that if, for instance, there isn't a resupply mission from Earth, the crew can survive. But pre-staging, pre-positioning of cargo makes a lot of sense. Spare parts and also consumables and food and water and so on. Yes. So Kristen is saying, how do we know if the meteorite that made the whole crater has water in its substructure before impact? We're guessing, or we know. Well, we suspect is the correct answer. We suspect there has been satellites that go over the craters, and they have sensors that can detect, I think it's neutron detection, or they can basically detect anything coming from the crater. And occasionally you do have meteorites or whatever hitting the moon, and if they hit the crater area, you get volatiles, which can be detected by the satellites. So the correct answer is we suspect, or strongly suspect, there is, based on sensor data, there is water in the craters. So we won't know for sure until we go there, and that's the plan, to send scientific equipment or whatever, rovers into the craters and check. So that's what NASA hopes to do. That's why they're going to the South Pole, because they suspect that's where the lunar water ice is. So the second video I did this week, if I can bring it up, there it is lunar rail network. So in terms of infrastructure, the obvious piece of infrastructure, and the very first one is roads. I think we all agree you want roads on the moon, just so you can get from the landing pad to the habitat, from the habitat to craters or scientific areas of interest, just basically to move around roads are very useful, but they do have drawbacks. And so in the video, I compare roads to rail. Rail is obviously probably 10 years further down the track, so to speak. It's you start with roads first, obviously, because roads are quite easy to do in comparison. But you want to consider rail. And again, this was part of DARPA's Lunar 10 architecture study. This time, the concept came from Northrop Grumman, a very large aerospace, US aerospace company. They do all kinds of defense stuff, but they also do space stuff as well. So they came up with the idea, or they proposed the idea to DARPA of a lunar rail network. So I did a video on that. Basically, the first thing I did was compare it to roads, because the question is, why not just use roads? Roads are a lot simpler. You can move around with roads. So I did get some pushback. One of the comments said, I compared using rovers over unprepared ground to a rail system, and I should have compared prepared ground roads versus rail, which is okay. That was a good pushback. But some of the issues with rovers are nothing to do with whether they have a road or not. It's to do with their onboard power system. The power comes from a very large, inefficient battery on the rover, and that limits the range and the payload capacity. And there's just no getting around that issue. Is that batteries are not very energy efficient. That's why no planes use batteries. And with rail, you have an off-board power system. You have overhead lines. You have some kind of integrated power nodes along the track, or beam power, or you have solar arrays on the actual train. But it's a separate system of where the power's not on the train, and that makes it a lot lighter, a lot more efficient, and it means it can send cargo over much longer distances much more efficiently. So that's why on Earth, whenever you're dealing with mines or whatever, or you need to move a lot of material quickly over a long distance, you use rail. Like mining sites don't use trucks. They use rail. So the challenges with roads are, first of all, you kick up a lot of dust with rovers. Some of the video I showed from the Apollo era, you can see a massive amount of dust being generated as the rover's turning or even moving. And that dust goes everywhere. It goes over your science experiments, over the solar panels. It clogs your cooling venting systems, which causes systems to overheat. It can go over your habitat. It's not great when you get a lot of dust being kicked up. So that is solved by rail, because you have, first of all, you have prepared ground, you have an embankment, it's all cleared, the ground's sintered, then you have the sleepers, and then you have the rail tracks, and then you have the train on top. So you get very little dust being kicked up. So it's just a lot better for everyone around the rail track. And also you can seal the undercarriage as well, so none of your cargo gets dust in it, which is great. And also the cost. There's obviously a big upfront cost to rail, but once you've built the system, the running costs, the recurring costs are quite low. It's just like power and maintenance, inspection and so on. So compared to rovers, which because of all the dust and so on, the wear and tear, the bumping up and down, you have to replace the components or the entire vehicles. And another issue is that when you scale up, you've got more people, you've got tourists, you've got more dump trucks, you've got more scientific equipment, more people going to and from the landing pad. You need more rovers, which means you get more dirt being kicked up. You've got more traffic using the roads. You've got more congestion. So it gets worse and worse as you scale out the habitat. So I think rovers fantastic for a small base, small to medium. But when it starts to expand and get larger, you're going to have a lot of problems with rovers. So you want rail. So you can kind of see how they intend to build it. It's going to be autonomous rovers. It's going to be clearing the path. It's going to be building embankments, doing the sintering, then laying down the rail track and the sleepers, and then you got the masts for lighting and security and communications and so on. Perhaps using lunar saber masts, and then you've got the warehouses and the switching yards, the power substations, control center, and so on. And companies like Icon Technologies can 3D print these areas, these storage areas, the warehouses. So it's not just Northrop Grumman. You've got Honeybee providing the masts. You've got Icon Technologies or other companies doing 3D printing the stations. You've got maybe other companies providing the rovers. And then you've got companies like Cislunar Industries, which I may do a video on Cislunar Industries, but basically they're providing a foundry. So you can see you've got inputs, various inputs. So it could be ISRU metals. You process regolith, you've got metals, aluminium, iron. It could be various imports. It could be scrap metal, disused rovers, scientific equipment. You can just collect it, put it into the foundry. It could be slag. It could be deoxygenated regolith. So certain companies like Ethos, they're extracting the oxygen from the regolith. So then you've got this byproduct that can go into the foundry. And you get metal ingots, you get rail tracks, beams, sheet metal, cables, wires, and mining equipment. So there's all kinds of products you can get out for railroad, warehouse space, solar concentrators, and power transmission. So that's your foundry. And then basically from the foundry, the lunar mass, and Northrop Grumman's rail track system and rolling stock, you've got yourself a rail network. And here's one of the graphics. You can see, I think this looks like Shackleton crater on the right, and you've got this crater. Maybe this is Dergalash, I'm not sure. And then you've got these yellow lights are peaks of eternal light, which is basically areas that have almost continuous sunlight the whole year round. Probably 85-90% of the year they see the sun. And then you've got the white spots, which are potential landing pads. This is just guesses where you put the landing pads. And then the red lines are basically rail track. So you've got rail tracks to the landing pads and all around the craters, and then in between the craters. Maybe you'd have the base camp in between somewhere, something like that. So, and Kristen is saying, rail, this is very ambitious. We need to build something small to find what is where. Most likely something like a harvester truck, something like from movie June. We start small with roads, and then you build out your road network. But perhaps 10 years down the road, when you've got foundries, when you've got a small base camp, when you've got nuclear reactors, you've got science experiments and so on. At that point, you may want to consider building rail. Rail is very useful when you start harvesting local resources. I think before you start to harvest, rail isn't that useful. But once you start processing thousands of tons or millions of tons of regolith, which is what you need to do, if you are looking and prospecting for helium-3, you have to prospect millions of tons. Rail makes a lot of sense on the moon. Perhaps not the first decade, but I think the second decade, once the base starts to expand, it makes a lot of sense. And also, Kristen is saying, very familiar with the works of Dr. Zuberman, how to cook the soil or rocks to get vapors and recover it, like water or oxygen. And the concept is very simple. If you apply heat to the ground, volatiles will basically be emitted. And if you capture that in some kind of put some kind of cover, some kind of cold trap, it's called. The volatiles are caught on the cold trap. They trickle down. You capture them, and that's how you get lunar water ice. So yeah, we don't know how close to the surface lunar water ice is. We just have to see, right? And the only way to know for sure is to go into a crater and do your scientific experiments. Try to extract some water and see how it goes. Yeah, there's just no way around that. I mean, that's just what you have to do. So some of the comments, there's quite a few comments on Lunar Rail. One of them from Domi Trulangam says, I hope it is on time and cheaper than Earth-based railway. And George Vajajish says, I don't think that's how building stuff on space works. Yeah, I mean, it's not going to be cheap and it's probably not going to be on time. Let's be honest. Yeah, so yeah, it's going to cost a lot of money and it's going to take quite a bit of time. But they're going to start with a test track, just 200 meters. They call it the minimal viable experiment. And it's just 200 meters of test track and near a mining site. And they're going to try and deliver a small amount of materials and sell the cargo for, make a commercial sale to begin with, which I think is a great idea. And not less Grossman says, why are you moving around in the first place? Where are you going and why? Many early, and Ham Judo says, many early railroads on this planet were built between where an ore was mined and where it was processed. That's, yeah. And Gaius Enceladus says, exactly. They were built as an easy and efficient way to get to resources and to transport those resources to where they would be used. And many villages and towns sprung up near those resources. Yeah. So it's going to be the same on the moon. You're going to have a rail track to resources, and then you're going to move the resources to a processing center or near a landing pad for you've got propellants. You make propellants, you then put them at the landing pad where you can store them in storage tanks for landers, for instance, or back to the base camp. And Tim Robertson says, do you plan on making the train and tracks out of lunar regolith? Yes. Where are the metals coming from? From the foundry? Not Earth. Not likely either way. Robots will not last long on the moon due to lack of maintenance and moon dust wearing them out quickly, I would guess. So there's going to be a certain amount of wear and tear, that's for sure. But that's why they're doing a very small test track, and that will be generation 1, and then you'll have generation 2, which is part of the plan. You'll have better equipment, better robots. They'll lay the track faster. The rail engines, the rolling stock will be better. So it's a gradual process. No one's thinking the very first generation will be the best. It will gradually get better over time. And more comments. Jacob says Labour, and Peekaboo says, in about 10 years, sending a good amount of humans to the lunar surface shouldn't pose much of an issue, so a good handful could help with construction. But in my opinion, the lunar industry complex will largely be built by autonomous worker robots, much cheaper than people and expendable. Exactly. The plan from Northrop Grumman is, and if you look at the graphic, I don't know if I've got the graphic here. Yeah, I've got the graphic here. If you look on the left, there's rover vehicles, there's excavators, there's assemblers. It's all robots. Practically all the way, it's just going to be robots building the system autonomously. It's just, yeah, it's cheaper and it's safer, and it means rather than like the 6 days that that the astronauts are on the moon, you can do it 365 days a year. You can assemble and lay down the track continuously during the lunar day, during the lunar night, if you use robots. And Gaius Enceladus says, agreed. Heck, there are even huge robots that can 3D print a house now using extrudable materials. Icon Technologies does that. They've already built a Mars June Alpha. They 3D printed a Mars prototype analog base, and crew spent Four crews spent a year in that 3D printed space, and there's another crew that will be joining that station soon again. So there are companies that can already 3D print an entire habitat, and they do that on Earth. They do it in Texas, but they also have printers for the moon, so that not be a problem. They can 3D print the warehouses for the rail track network. Survey the proposed course, grade it and level it out, create mooncrete for sleepers, lay sleepers and rails. As engineering challenges go, there are far more difficult ones that have been done. Building railways through mountains and under the sea. So yeah, it's not the world's biggest engineering challenge. There are companies that already have the technology, they have the robots, they have the equipment to do this already. Many companies are working on road preparation, and rail site preparation is very similar. Redwire's working on it. Astroport's working on it. I've done videos on them. So this is definitely doable. And George Vajagish is saying, sorry I butchered your name, sorry, but simply better lunar roads will make a lot more sense than trains for most tasks for the next few decades. A lot of the issues mentioned with roads can be fixed for less than the cost of building a whole lunar train network. We won't have the needed population density on the moon for a while. Small experimental trains on the moon would be fun though. So yeah, the first decade we're probably using roads. They do make a lot more sense. They're a lot cheaper, they're a lot easier to do, and they're fine, I think, for the first decade. In fact, until we are mining, processing lunar regolith, the need for rail isn't great. But once we start to do that, and we really start doing it in commercial terms, that is hundreds and thousands of tons, rail will make a lot more sense. And then John Anderson says, I wonder how the metal tracks will manage the huge gradient of temperature between lunar day and nights. Buckling will be massive. I would personally go with a monorail with a central rail made with melted regolith obsidian, or better, an underground metro tube bored with a gyrotron microwave tube digger, melting and sealing the tube as it goes, more reliable, less radiation, maybe even pressurized, ? Plus the excavated material can be reused for surface construction. And Jumi Trulangam says, maybe build the whole thing underground would be safer. And Non says, or use plastic and not load them as heavy on Earth, as gravity is very low, so not the same material needed. And also someone says, lunar tube, like in the movie Ad Astra, between different bases, it's also pressurized as well. And then also, just on the same idea, Paul Hinbush says, if you use prefabricated tubes on legs, you can get a system up and running quicker, and then you bury the tubes to protect them and have a hub system protect the system from lunar regolith. I mean, tubes do make a lot of sense. You can run them straight. You don't have to worry about craters on the surface. You don't have the radiation issues. You don't have dust. They do make a lot of sense, but I don't think it's the first or maybe even the second decade before we're boring tunnels on the moon. But I do like the idea of boring tunnels on the moon and on Mars. I can see a lot of advantages for habitats, for warehouses, for storage, for rail, for underground road systems. It does make a lot of sense. But I think it will probably be the second or third decade. But, I mean, I do like the idea. And what does Kristen is saying? Extraction of frozen water vapors need to be done in pressure and G environment. Something like huge pressure vacuum requires a huge amount of energy. Zubin worked with tracers of water from collectors. He got like half a drop of water. We need to do way better than this. A single astronaut have to have 1 litre of water a day to recycle it. Yeah, there's a lot of technology we need to figure out to extract water at scale. And for commercial harvesting, it needs to be at scale. There's various ideas. We just have to deploy them on the moon and see what works. Yeah. So hopefully that will happen in the next decade, the next 5-10 years. We have lunar landers going to the moon all the time. Blue Ghost has a successful mission. It's got another 2 missions. You've got intuitive machines. You've got iSpace. There's a lot of landers heading towards the moon. And then, of course, you'll have SpaceX Starship. You'll have Blue Origin Mark 1 and Mark 2. So there's a lot of craft going to the moon. And hopefully they're deploying a lot of equipment. And we'll figure out the extraction, how to extract lunar water ice at scale. And Ken Moore saying, in the illustrations, the rails are shown laying on what appears to be conventional railroad ties. Yes, I understand this will be made of some composite material from the regolith, but that's not my issue. What concerns me is how well those ties will work laying directly on the moon's surface. Given the squishy nature of the ground material and the weight of the loaded train cars, the ties will need to be supported. Will these ties cover enough surface to stay level and remain in place? I wonder if they may need some sort of pier driven into the soil for the ties to set on. Think house foundation repair here on Earth. And Marty the Martian responds, I'm assuming that just like here on Earth, a roadbed will be prepared before the tracks are laid, with the loads being 1/6 of the weight when compared to Earth trains. There would be far less compression, especially when you consider the track and ties spread the load even more. Wheels put all their downward pressure on a small patch. This is one of the advantages of rail, is that the load is spread over a much wider area because the whole ground is flattened, it's compressed, it's sintered. Then you have the sleepers going across and then the rail track along. And then you have multiple coupled cars which spread all the pressure over a much wider distance onto much flatter compressed ground. So basically the load is spread over a much wider area, and that's why it can carry 125 tons per car. So you've got multiple cars, each with 125 tons. You can move a lot of cargo across the surface. If you've got them coupled, you could have thousands of tons moving one coupled car, one train set of cars, right? 8, 10 of those, 12. You got 1,000 tons. So that's the idea. I mean, that's what happens on Earth. So I assume it would be the same. And Geis and Salad are saying, this is great. I'd love to see this happen. Okay, there are challenges, like how to handle changes in temperatures between the lunar day and night. But with time and good engineering, I think those challenges can be overcome. Go Northrop Grumman. Precisely. There are challenges. There's like a lot of things that have to go right. There's a lot of technology you have to develop. That's why Northrop Grumman says start with a test track. I don't know if I showed this graphic, but basically you can see there's a whole series of phases. Phase 1, the MVE, which is the minimum viable experiment, just 200 meters, test out all the equipment, test out building the network, rolling stock, try delivering some cargo, and then you go to phase 1, 2, 3, 4. You gradually expand the rail network over time. Could be a decade, could be 2 decades, who knows? And you only expand the network based on commercial justification. So if there's a commercial need to expand the network, you'd expand it, which makes sense, right? So on to space startup news. So I covered a few things, 2 moon-related issues, stories, and then this is Stoke Space. So if you're not familiar with Stoke Space, bring up some of the photos. They released some photos. So the testing there, stage 2. So they have 2 stages, stage 1 booster, and then on top you have stage 2. The entire system is fully reusable. So more reusable than Falcon 9. The second stage, which you can see here, comes back. It has an active shield, and it comes back and lands. Retro propulsive landing. So it's a fully 100% reusable system, and with a lot of new technology. And they've been testing, pressurizing, unpressurizing their stage 2 system. Here are the photos. So it's passed. So it's they're ready to launch next year, hopefully early next year. They're working on their launch site, Slick 14 at Cape Canaveral, historic launch site. So hopefully they will be launching in early 2026, and this will be another rival to SpaceX. So we'll have Rocket Lab Neutron, medium lift vehicle, 13 tons. Falcon is about 22 tons. I'm not sure what the payload is for Nova vehicle, but it's a fully reusable medium lift rocket. So it definitely will be competing with Falcon 9. So SpaceX will get a lot of competition next year, hopefully. And also from Europe, you maybe have PLD Space and so on, and Rocket Factory Augsburg and ISAR Aerospace. So Christian is saying, even if we could count on Elon to make 1 kilo for $100 to high Earth orbit, this $100 would have to be like the moon delivery for mining to make sense. Elon says to have a ship to move 200 tons on one load. So the only material or resource that would be profitable to mine on Earth, mine on the moon, and send to Earth is helium-3. That's it. Nothing else makes sense to return to Earth. It made sense on the moon for tourism. I'm sure space agencies or science missions would pay for a small amount of resources. If you've got power, you can imagine science experiments paying for beamed power, paying for lighting or asset management or navigation and communications. There's a lot of services that you can that you would buy or sell on the moon, but you would not send them back to Earth. The only exception, the single exception, is helium-3, I think. And Marty the Martian saying, second stage gets so much attention that I am yet to see stage 1. I assume it's out there, just doesn't get much media. Yeah, the Nova vehicle is very, very interesting. There's just so much new technology. You have the Aerospike engine on the second stage, and if you're not familiar with the Aerospike, it's just they have, I think it's 24 small engines on the rim of the second stage. It was 30, I think it's 24 now, and they all fire, and it kind of makes a very it makes it into an efficient nozzle. It's not a real nozzle, but all the engines firing together makes it into a very efficient way of propelling the second stage. I've not explained Aerospike very well there, but basically I have a video on Stoke Space. I explain Aerospike engines better there. But basically that's novel. Then you have the active shield. At the bottom you have liquid hydrogen, which is the propellant, and it vents off and cools the bottom area, which gets hot. So this is the bottom bit faces the atmosphere as it comes back. It gets very hot, but with active cooling, there's no tiles. It's actively cooled, and then it can propulsively land. So very, very fast turnaround of the second stage. And so this is potentially a very reusable vehicle. And as I say in the video, rockets only make money when they fly. A rocket on the ground makes no money. So Stoke Space is very exciting, and hopefully they launch next year. And I also talked about Firefly Aerospace Blue Ghost Mission 2, which is going to the far side of the moon. So the moon is tidally locked. That means you see the same side. Whenever you look at the moon, it's always the same side. You see the side with the craters and the mares, the volcanic areas that have solidified and are quite flat, the dark patches. But on the far side, I don't think there's any mares, if I'm correct. So it's very different kind of terrain. So the mission 2 is going to the far side. There will be a lunar orbiter that will do the data relay, because obviously you can't communicate with Earth directly if you're on the far side. So you have a satellite in orbit. The lander communicates with a satellite, which then communicates with Earth. So it's kind of a bent pipe communication system. So, and it's a dual spacecraft configuration. So you've got the lander on the top. This is a Blue Ghost lunar lander. And then at the bottom, you've got the electro-dark orbiter, which will stay in orbit, providing communications between Earth and the lander. So that's Blue Ghost mission 2. So the first mission was 100% successful. Very, very successful mission. The only one. NASA had 4 CLPS missions, commercial lunar payload services missions. Only one was fully successful, and that was Firefly. Intuitive Machines had 2 missions that kind of fell over, and then there was it Astrobotic, the Peregrine lunar lander, which kind of didn't make it from Earth orbit. It had some kind of issue and just went back into the Earth atmosphere and burnt up, which wasn't great. Marty the Martian saying, I wonder if Firefly has plans for a heavier lander in the future. I don't know the answer to that. I think they're going with the Blue Ghost at the moment. They've got another 2 missions. So mission 2 and mission 3. This is mission 2. They have a mission 3. Intuitive Machines, I think, has 4 missions. They've flown 2. Not successful. They've got a mission 3 and a mission 4. So iSpace US is building a larger lunar lander. And then of course you've got Astrobotic. They're working on their second mission. So yeah, there's a lot of lunar lander missions coming up, which is great. And hopefully some of the space startups can get their technology, their equipment, their rovers on these missions, especially Starship and the Blue Origin Mark 1 lander, so they can start testing that technology, which would be great. And yeah, here's the actual lunar lander. There it is on the top, and then you'll have the orbiter. You'll have the orbiter as well. So it's built. It's now going for testing, and launch is, I think it's 2026. I said in the video. But yeah, the first mission was 100% successful. It was, everything worked perfectly. All the payloads worked perfectly, were deployed. Fantastic, couldn't have been better. So fingers crossed, their second mission is just as successful, because that would be amazing. So that is all the space news. Thank you for joining the live stream. If you didn't catch it live, you can watch it afterwards. I'm also planning, I may do this next week, I'm planning to make my space news video live stream, just because I can be more up to date. I'm not a day behind on the news. And so it's going to be a bit less polished. It's going to be me making show notes and then just being in front of the camera and talking about space news. And yeah, you can chat and bring up any space news I've missed. So that's the plan. Probably for next week, I'll do that. In terms of videos next week, I know what I'm doing. There's a brand new company, just got pre-seed funding. It's very interesting. So I'm going to talk about that next week first. That's going to be probably a fairly short video, because I just have the homepage and one news article to go off. But it's such a very interesting concept, I want to cover it. So that's my first video next week. My second video is again back to lunar infrastructure. I have a lot to talk about when it comes to lunar infrastructure. NASA funded some other projects. So there's 2 or 3 of those projects I want to talk about. They're very interesting. But my next one is going to be on, well, I'll tell you what it is. Basically, I've covered lunar roads. I've covered lunar rail. How about magnetic levitation? That's what I'm going to talk about. And it's funded by NASA. So this is like a study. I don't think it's actual hardware at this point. but I'm going to talk about that because that's another way of moving stuff around the moon. So, and Kristen says, great video, great chatting video, much, thank you. I have, and Kauf Mamba says, have you covered Dawn Aerospace's Aurora? I've covered Dawn Aerospace in one of the space news. Are they working on the detonation engine? I've definitely covered Dawn Aerospace. Is it Dawn Aerospace in one of my space news? I've not done a dedicated video on yet, but maybe I will in the future. And then also he mentions also JP Aerospace is lighter than air to space system. That's new to me. I don't know anything about it, but I will look it up and maybe I'll do a video on that in the future. So thank you for joining, and you may see me twice next week. Definitely I'll be doing this again next weekend, but in midweek I'm planning to do this format for space news. So I'm still doing space news, but I'm probably just I'm gonna do it as a live stream and see how it goes. So thank you for joining, and see you next week.